right, here we go with another example. Now this time we have an irreducible quadratic factor of degree 2. So just like we had with the linear factors, we expect this to be something over x squared plus 1, and then we expect another fraction to be over x plus 1 quantity squared. Now, if this had been quantity to the third, you'd have a third piece that would then be over x squared plus 1 to the third. Because these are quadratic factors in the denominator, we've got to make sure that we do the whole ax plus b thing. And this guy's going to be cx plus d over here. All right, let's see what we can do here. Hopefully it's better than the last one, right? So the ax plus b is missing the factor of x squared plus 1. And then you have cx plus d that's not missing anything. And this whole guy is equal to 3x to the third plus 7x squared minus 2x plus 9. All right, so like the last example that we did, we're not going to be able to plug in good numbers to get things to just go away, because these are irreducible quadratic factors and you'd be dealing with like imaginary stuff, and we're not doing that. Instead, let's FOIL things out and then start lining things up, saying, okay, these are the letters that correspond to my coefficient for x to the third, for x squared, for x, and so on. So when I FOIL this first piece, I have a x to the third plus ax plus bx squared plus b, and then this is just cx plus d. You can't do anything with that. And nothing on the right side of the equation changed. But now we'll start to see that this guy works out to be just a little bit nicer than the last one. Because when I look at things that are x to the third, there's x to the third and there's x to the third. There's nothing else. So it means that a equals 3. I don't know, I'm putting so much space there because I'm expecting to have a lot of things, but I don't really. So a equals 3. Let's look at x squared. So we have bx squared and 7x squared. Oh, that's easy enough. So that means that b equals 7. I'll take that. Then for the x term, you have plus ax plus cx and minus 2x. So that means that a plus c equals negative 2. I'm not going to fret about that because I already know what a is. And then the last one is going to be b and d. They're not connected to any x. So these are the constant pieces, and that's going to connect with the 9 that we have over there. So it means that b plus d equals 9. All right, make your life easy. All right. So we already have a is 3, b is 7. So if I take this guy over here, we already know that a is 3, so 3 plus c equals negative 2, c equals negative 5. Done. We just need to find what d is. So here, b plus d is 9, so 7 plus d equals 9, which means d equals 2. Done. Right. So when we write our answer here, the partial fraction decomposition, it was ax plus b, so that means it's going to be 3x plus 7 over x squared plus 1 was that first denominator. And the other one is going to be the cx plus d, so negative 5x plus 2 over x squared plus 1 quantity squared. Easy peasy, right? Sometimes they're nice and easy. You remember the last one, you look at the system that you had to solve, there was a lot going on with that one. But this one, I'll take that. I would even like to see that on the test. You would? What a great